Hello, and thank you for joining Fox Technologies' second in our webinar series on SSH security. My name is Mark Lambiazzi. I'm the CTO of Fox Technologies, and we certainly appreciate you joining us here today. Last week, we spoke about SSH and some of the tools available in SSH to control access and other aspects of your SSH service to provide security. We also touched on some of the problems with configuring and managing SSH access with the local configuration options that are available. Today we're going to talk about the who, where, when, how, and how of SSH access control. A little bit of housekeeping before we get started. We certainly would enjoy any questions from you. We're going to answer any questions that we receive during the webinar on our blog tomorrow. And you can ask questions through the GoToMeeting toolbar in the small chat section. There's an area there for you to enter and ask questions. So a recap of last week's webinar, quickly. So why are we talking about SSH? It's been around for a very long time, almost 30 years or so, and it's ubiquitous within enterprises and industries and within technology, embedded in many different places. Well, there have really been three things that have driven the visibility of SSH into the marketplace, and especially with many managers. If you're a sysadmin out there, you might have had people in the last year or two asking questions. And some of this is a couple of reports that were sponsored by a vendor. And in those reports from the Ponemon Institute and Forrester, they publicized some very scary numbers, some very scary statistics about SSH. Things like 75% of all enterprises have suffered a breach due to an SSH problem, or 50% of all enterprises do not have any kinds of policies around controls on SSH. These are really big, scary numbers, and they are tailored reports. They focus on some very specific aspects. More recently, US NIST has published a document, some guidance, number 7966. Again, a very tailored document. It is an analysis of the security issues that revolve around automatic authentication and SSH. So SSH has received a lot of visibility and a lot of attention over the last couple of years, and maybe you've been in conversations about it, or maybe those are about to come. But chances are somewhere in your enterprise SSH is used, and probably on a daily basis by administrators or applications to connect or move data. The other thing that we talked about last week was that SSH does have many configurable options. A number of these are around security of the SSH service itself, such as whether you're going to use the SSH2 protocol or one, or maybe you could allow both. These days, limiting your SSH deployments to SSH version 2 is highly recommended. There's other options for how the service itself runs, how it interacts with the base operating system, whether it has privilege separation or whether the service chroots and changes its privilege level. And then there are some access control options. We can control users or groups of users and whether they're allowed or denied. We can control what authentication options are enabled within our SSH service. And in our discussion of all of these options, there were really two things that we pointed out. First of all, that all of those configurable options are global options. So configuring our local SSH service, we really only have the ability to turn things on and off. So they lack a granular access control model. It gives us some control over SSH, and it can be very good control. But I'm going to argue in the next 20 minutes or so that it's really not enough. It's not granular enough for your enterprise to be able to do everything that it needs to be able to do securely. It just doesn't give you enough options. And the other problem that we pointed out was configuring and maintaining your SSH configuration on a machine-by-machine basis can be very difficult. If you have a small number of machines, if you have 10 machines, certainly it can be done. If you have 100 machines, it may be a little bit of a burden and take some effort. Might kind of tap into the time that your administrators could spend on more valuable tasks. But if you have 1,000 or 5,000, 10,000, or even some of our customers 50,000 servers, if you don't have some kind of centralized management model for many things, but especially for your security services, things can slip out and you can very easily lose control of the security of your environment. So who, when, where, when, how, and how. So what we're talking about is which accounts are allowed to use SSH, where, what host they can come from, when they are allowed to connect, how SSH can be used, what they're allowed to do when they use the protocol, and the type of authentication that we want the account to use when it is allowed to connect and authenticate. Now typically some of these can be done, but you can't pick and choose very easily different options for different accounts. So who are these accounts? Who is it's not a user, it's not just a person. To SSH, the who is an account. That account may be a person account, it may be a system administrator, database administrator, an application administrator that needs to access our Unix and Linux servers to perform their duties, to configure or maintain, to update or to modify, to start or stop the various different applications and services, or to groom data in the case of a database administrator. These are the people accounts. These also are typically accounts that have very high levels of access once they're on these machines. These are the privileged accounts within our enterprise that can go in and make modifications or access the data that is attached to our different servers. But they're not the only type of who where SSH is applied. We have service accounts, or also can be called functional accounts, or you can think of them as an application account. SSH is often used in enterprises for a secure connection from an application or from a server to another server. These are for automated processes. Maybe it's backing up data, maybe it's pushing data, or pushing a transaction from one server to another. Now, these are part and parcel of the applications that we develop in inter-application or inter-system communications, and we have to be able to push that data around. These accounts typically have to be handled in a different way. It's not a person, it's not an interactive session, it's not somebody sitting at a keyboard who can identify themselves to the SSH service to gain access. This is that special case that the new NIST guidance really revolves around, is these accounts and how we manage and control the access that they have when using SSH. And then there's some other accounts, and these may or may not be something that you want to allow SSH for, such as the root account, the all-powerful root on our Unix and Linux servers, the account that can do anything once it's there. Very simple options in SSH to go in and say that root cannot log in directly. But then root has some other issues as well. Typically not for SSH, but next week when we talk about some other topics, we're going to talk more about the root account and controlling and managing it. But there are other system accounts that exist, and they may or may not be appropriate for remote access to a server. Where? Should every account be allowed to log in from anywhere? Well, with administrators, it may be arguable that they shouldn't be constrained, or maybe they should. Maybe administrators should not be logging in to key critical servers deep inside the network from the VPN. Or maybe they should. Maybe we have VLANs, maybe the IT can come in on a separate VPN and be granted address space, and we can handle them very carefully. But our regular class of remote access users should not be allowed to. Maybe the IT VLAN is in a known location on our network, but that computer out in the reception area, the administrator really shouldn't be trying to SSH into the crown jewels of our enterprise from out on the patio or out in the reception area. Maybe not every computer is best suited for accessing our mission critical servers. So it has a lot of value to be able to limit the where, even for our people accounts. But for our service and functional accounts, this is actually something that should be pretty simple to define. And it's a nice addition to the security posture of our SSH service if we know that one of these functional accounts that is going to perform an automatic authentication, let's say a backup script, for instance. Well, that backup script is running on a known server or a known group of servers. Well, that backup account, we should really limit it to only be able to access our servers from where we know it should. It's low-hanging fruit to be able to go in and to define this. So combining the who with the where, we're talking about accounts here, and now we're talking about layering more types of rules more dynamically on top of how those accounts can be used. When? Well, again, administrators may be hard to confine. You never know. It depends on the enterprise. We have some companies as customers that only want their administrators accessing these key critical servers during business hours when that person is on shift. They have a rotation, they have a 24/7 operation, they provide a critical service, and if you're not on staff at that time, you shouldn't be going in. So there are some ways that we could do this and constrain our end users. Not every time, but once again, a really good tool to have in the bag to be able to perform our granular access control routines. But now let's talk about the service accounts again. These functional accounts, again addressed in the NIST guidance on automatic authentication. Okay, these functional accounts, if we have a backup script that we run every night at midnight, well, then during regular business hours, that backup script shouldn't be running. Now, all three of these different constraints, these mitigating controls that we can put in place here using box server control, these are enforcement tools. So if somebody tries to access a server outside of the hours that we've defined, well, we're going to know, and it's going to be enforced. They will not be granted access, and we will be alerted to behavior that is outside of our policy. If a service account or a functional account is trying to access our SSH services outside of the hours that we have defined for them, well, not only is that not going to work, but that becomes a detection method to not only block bad behavior, but to alert on the bad behavior so we can go and find out what's going wrong in our environment and ferret out the problems that may be growing inside. So attaching where and when to an account are powerful tools. And right there alone, we have some really good tools that can be used to constrain these functional accounts and to enforce our policy and to detect when things are acting outside of policy without allowing for access. Now we can talk a little bit about how. Our administrators need shell. Maybe our administrators should not be moving data off of those servers. Maybe we know that they need to go and run commands, but they should not be siphoning information out of the enterprise to do their job. Same thing with SFTP. Our functional accounts, on the other hand, maybe they need shell. Maybe they're running interactive commands to be able to perform their activities. But in the example of the backup script, absolutely not. That backup script would only need access through the secure copy service to be able to perform its task. So another layer of control that can be layered on top of how a particular account is allowed to access a particular SSH service. Because not only can we define this and place these rules on an account, but we can do it on a server by server or group by group basis. So maybe this administrator should be allowed to do one type of activity on one set of servers, and maybe it should be more constrained on another. An example could be developers. People developing applications in the development environment, in the test environment, maybe it is safe to grant them a higher degree of access. But for an application that's been promoted into production, access into that production environment, maybe that is constrained to a smaller group of our employees whom we trust to manage and maintain our production environment and applications. So we can layer how on top of the account in addition to the other tools that we have to manage the secure remote access into our servers. The other how in SSH access control is the authentication type. And there are a number of types of authentication that we can integrate with SSH, and they're all very good. Many companies are looking to centralize the identities within their environment. I talked about the value of centralization earlier in the vein of talking about managing our SSH and how managing a large number of SSH deployments could be a large burden. Well, if we have one user on 10 servers, that's easy. If we have 10 users on 100 servers, well, that gets a little hard. That's 1,000 accounts. If we have 100 users on 1,000 servers, 10,000 servers, if we have 100 administrators on 10,000, 20,000 servers, not all of them belong in all places. Different administrators should have different kinds of access or be able to do different tasks or only access one group or class of server. It can become very daunting to go in and manage those identities. So centralizing authentication through something like Kerberos has become popular. But Kerberos is not always a popular solution in some enterprises. SSH keys are often considered a more secure authentication method. And tokens are still very broadly used, using one-time passwords and applying those inside of SSH, something Box does quite well. to provide for that strong authentication when accessing? Well, again, let's talk about our functional accounts. And SSH keys are among the most popular way for these functional accounts to authenticate. In the key-based model of authentication, we can install an SSH key that we've created, and we can place a copy of the public portion of that key on our server. And in most cases, a functional account can't type in a password. If it can type in a password and it's automatic authentication, well, that password's probably in a script. So if you think about it, if somebody compromises that server, they're going to get the key, they're going to get the password, and that key is now compromised. There are some ways with functional accounts. We could use an SSH agent to not leave the decrypted key on disk and only hold that in RAM. Pulling that key out, a much more difficult task for an attacker. But that presents its own functional problems. If a service crashes or the system restarts, it'll take a manual intervention by an administrator to reload that key into memory so it can be used. Maybe not something that is too much of a burden for some servers and services and enterprises. Sometimes it is too much for others, and they've made the conscious decision not to allow that. Same problem with administrators using keys, though. Keys are just little bits of data, and keys can be stolen. But let's think about the who, where, when, how, and how that box server control applies to authentication. Let's take that functional account, and let's say that we have an SSH key with no passphrase. Well, I can go in and I can say that this account coming from this host during this time period over this SSH subprotocol can use this key. That is a very tight control. The stolen key has no value. To compromise it, the compromised server would be the only platform where that compromised account would be able to even attempt an access. And that really narrows the vector with which we're at risk due to these types of compromise. We've tightened it down quite a bit. And if somebody doesn't know that we've applied a time slice, a window, when that should be usable, now we have detection along with our enforcement and our granular layers of rules that we can apply to the account and how it can access. Now, there's also another kind of authentication that could be used for this automatic authentication. It's called host-based authentication. Basically, well, we know that this account on this server is going to that server, and we're going to build a trust model between the two servers. Often, in the default SSH configuration, the tools that are available, that just is not trustworthy enough. However, many FoxT customers have come to understand that with the layers of the constraints we place on authentication and some things that we do that I haven't talked about, which enhance the integrity of the trust between two servers, that enhanced level of trust means that maybe, and some of them do functional account authentication, this automatic authentication, without leveraging SSH keys. And if you're going to use SSH keys, that means that you really need to implement broader-based key management policies, and not only implement them and adopt them, but to practice that. And practicing key management is an additional administrative burden. It's a maintenance overhead. So there are some alternatives. So taking all of these rules and putting it in one place where we can manage the accounts, we can manage the accounts in different groups. We can have our Oracle administrators, our systems administrators, Apache administrators, applying them to different servers or groups of servers, our web servers, our database servers, data stores. This allows us to take our rules defined in one place where we can take those rules and demonstrate to our auditors that we are implementing our policy and abiding by it. We are compliant with the rules that govern our industry. We can centralize all of the configuration and reporting on the access controls and the access granted across our Unix and Linux estate for the SSH service. We can do that for many users across many servers. We can create that account and populate it only into the servers and grant access only in the places where that account is required to have access. Adding accounts to servers can be a huge administrative burden. You get one new administrator and he's a senior sysadmin and he needs access to 1,000 servers. It is tough to touch 1,000 servers. But even more important than that is if that employee were to leave, removing those accounts. Simplify the deprovisioning of stale or terminated accounts to make sure that only the people and the services have the access that is defined by policy to be granted to them at all times. This is one of the key values that Box Server Control offers, is the centralized management of accounts and granular access control to the Unix and Linux domain within an enterprise. So we bring those things together, and we bring some additional tools to the enterprise within Server Control as well. Box Server Control can manage accounts. It can manage accounts centrally. It can provision them out into local systems across Unix platforms, across many different flavors of Unix and Linux. It can manage the access rules in a granular way, applying the who, where, when, how, and how of SSH access control to our enterprise systems. And the last thing that Server Control can do for us is manage privilege. And we're going to talk more about privilege management and where it fits in our security posture and in securing our Unix and Linux domain next week. So please join us next week. We'll be happy to hear from you, and you can learn about how Box Server Control implements privilege management integrated with SSH access control and account management across Unix and Linux platforms. Please feel free to reach out to us if you have any questions or would like to learn more about Box Server Control. We certainly appreciate your time today and your interest, and we hope to hear from you soon.